Hello, hello. Today we are going to take a look at this case called Seamstress Fast by Peter Scharl. This is the third case from the afternoon session of this year's Excel World Championship, and it is a fun one. Let me read the instructions here for you. Seamstress Fast is the greatest singer-songwriter of our generation, and she just finished up her Eons tour. You are an analyst on her tour and will get to stay on the team if you can be fearless and help calculate tickets price information for all her concerts. Each level introduces an aspect of how to calculate ticket price information, progress through the levels, and reach the end of the game by filling in the blank spaces for each answer in column E. And then we have several tabs here. So we have a tour list. So we have a list of all the tours, the dates, the cities, and so on. We have a map of the stadium here, which we are going to use to help calculate ticket prices later. And then this is an interesting one. We have another tab for anklets, and this is purely for the bonuses. And this case was unique in that the bonuses had nothing to do with the case details itself. So it's completely independent. You could solve the bonuses if you want, before, after, in between the case. That was really fun. But yeah, follow along with me. Let's see how long it could take to get a full solve, and here we go. Level 1. What is the sum of the concert numbers that occurred in the given city? So we have a city, we got to find the sum of the numbers. I'm going to go to my tour list. I'm going to turn this into a full-on table here. I'm going to just call this concerts, so that's easy to remember. And this first cell here, I'm just going to call that numbers. So what we're going to do is we're going to sum this concert number, where concert city refers to these cities over there. And that should give me all my sums. Level 2. Find the cost multiplier for the given concert numbers. Cost multiplier equals the day of the week multiplier times the city concert count multiplier. The day of the week multiplier depends on what day of the week the concert is on, for example, Sunday or Monday. The city concert count multiplier depends on the count for the concert within the city, for example, the first concert in the city be 1, the second concert 2, etc. The count depends on all the previous concerts in that city, and they do not have to occur on consecutive days or stops. The multiplier information can be found on the tour list tab. If the base price of a ticket is $2,500 and you wanted to buy 10 tickets, how much would you pay in total after applying the cost multiplier? All right, so a lot of information about the cost multiplier. Because this is going to depend on the information in the tour list table, I'm going to put this here for now, and let's figure this out step by step. So first, let's figure out the day of the week multiplier. It depends on what day of the week the concert is on. Now, we don't have the days of the week in this table. Instead, what we have is we have a month name, a day number, and a year number. Now, what we're going to do is we are going to turn that into a date. And I'm going to do that by using the date value function. So I think about how we typically write dates in the US. We can start with the month, comma, the day, space, and the year. And that should then, Excel should be able to turn them all into, no, it did not. April, oh, the comma doesn't go there. The comma goes down here at the end. There we go. Now it turned them into proper dates. So now what I'm going to do is I'm going to turn them into weekday. So all we need to do that is use the 4D text value. That will turn them into weekday just like that. And then this is going to be weekday mult. So to do that, we're going to XLOOKUP the weekday within this list here, which has the weekday and the respective multipliers there. Let's turn that into a number. There we go. Now I need to do the same thing for the city concert count multiplier. So it depends on the count for the concert within a city. So we have cities here. And what I'm going to do is I'm going to do another 2 columns. I'm going to do city count. So I'm going to count ifs where the city equals the city there, and where the date is less than or equal to, why did I not finish? Because I forgot to put an and sign. The date here. So that's going to tell me how many concerts occurred before and on the current date. So the first one should be 1. And there we go. And then we're going to get the city count mult is going to be, once again, another XLOOKUP. Not clean. I gotta find out what that does. XLOOKUP that count number along this table and return the multiplier there. There we go. And then finally, we need the cost multiplier. So to get the cost multiplier, so cost mult is what I'm going to call it. That is day of the week times city count. So day of the week multiplier is there, city count multiplier is there. that gets us a cost multiplier for all of these concerts. Now let's go back, because the question is not just asking for that cost multiplier. The question is asking, if the base price of a ticket is $2,500 and you want to buy 10 tickets, how much would you pay in total? So we are originally spending $25,000, right? And we need to multiply by that multiplier. So we're going to X look up this. Oh, I got to put that in a formula. X look up this concert number here against concert number, return concert, cost multiplier there. That will get me the answers for level 2. Level 3, in which row of its tier is the given seat? The layout of the stage and seats can be found on the Stadium tab. In the floor tier, the row number should be assigned based on the number of seats between you and the closest point of the stage, including diagonal movement. So we're looking at which row of its tier is the given seat. So let's take a look at the Stadium. Now we have this nice map here. We got colors which represent the tiers. Now a lot of times what I would do first is I would find and replace by color, but since these are all squares, I think it's going to be easier just to put the numbers in myself. So what I'm doing is I'm highlighting the area and I'm typing a number in, and to fill in all the cells, it's just a simple Control and Enter. That'll fill in all the highlighted cells with whatever you are trying to put in there. So there we go. Now I'm going to count floor as 0, and then stage, let's do X for stage. So I'm going to put stage in here and X there. All right. So now let me just go ahead and call this Stadium, and let's start a flat map based on this stadium. So we're going to do row, column, and then address, sorry, and then tier. So row, to call map stadium, row, to call map stadium, column, and then address is based on those two, and then tiers to call stadium. Right, so then whenever something is on the stage, we're getting an X there. So like if I look at A2, that's on the stage. That should be an X. Good. Now the question wasn't about the tier, it was about the row within the tier. So I am going to try to do this in a formulaic way, but the way I'm going to try it is going to involve circular references. So let me make sure my circular references are on. Iterative calculations, good. Okay, now to do this, what I'm going to do is I'm going to see if there's ever a smaller number next to the cell I'm working on. And if there is, then I'm going to count that as row 1. So if, let's see, count if any of the 9 surrounding cells are smaller than the current cell. Right, we're going to count that as 1. Otherwise, we're going to take the minimum of the numbers around us and add 1 to that. So you see here, we're going to get a 1 because there's nothing else. But when I fill this in, I'm going to paste by formula. Now, it is generally working. So I look at tier 5, and I am getting 1, 2, 3. But the rest of the tiers are not working. And that's because this tier 4 is counting against the first row in tier 5. So those, I'm just going to replace those manually. So let's look at the last row in tier 4. So that's going to be 3 rows there. The last row in tier 3, that looks like that's going to be 4 rows. So I'm going to highlight all of these. Same thing with tier 2, that looks like 4. I'm always cautious about doing manual approaches because I don't trust myself. And I didn't see this at first, but it looks like 2 rows are incorrect here. So let me just, I'm going to do this just slightly differently. I'm going to highlight it this way. So that's getting the 4 there. I'm going to turn that into row 4. And then this is going to be row 5. Now, oh boy, this yellow, this white part's done totally wrong. And I'm a bit worried because this is by far the hardest one to do. So I'm just going to try to highlight all the cells around the stage. So all the cells that border the stage, I'm going to highlight that. Actually, I highlighted that one in the stage, but that's okay. That's going to be row 1. Now all the cells around that. I know this is a tedious process. There's probably a good formulaic way to do this, but I don't know it. I don't want to spend all the time thinking about it. That's row 2. Okay, so we're getting close to the edge here. This is going to be, I'll get that, row 3, and then all the way out around out here. Yep. There we go. So that's going to be row 4, and then I think all the other cells, they're not touching anything. That's going to be row 5. There we go. So now I got all these rows of the stage. Ooh, do I want to put an X there? I think it's fine because we've already got the X. I don't think we need to put another X in there. So I'm going to call this row in tier, and we're going to call this map there. All right. Now, if I did that right, I should be able to do a nice X lookup. That's seat number against the address column, return row in tier. Do I get number 2? Yes, I do. Fill that in. Do all these check out? Yes, they do. Excellent. Now, one thing is with iterative calculations, I'm just going to double check. Good. They're all pasted as values. I want to keep them as values because those numbers are going to be stable, and I don't want them recalculating all the time because that's going to take up a lot of resources. Level 4. What is the distance to the closest point of the stage from the given sig in feet? The distance is measured as the number of cells, including diagonal movement between the seat and the closest point on the stage. Multiply by 3 to convert it to feet. For example, seats X9 and X10 are both 1 cell from the stage, which means their distance is 3 feet. All right, so we're going to do another one of these. Let's do another map here. And now no, actually this could, whoa, no. No, not formula, that's formatting. There we go. And then what I'm going to do, so because I left the stages blank, I think this can still work. So if this cell is blank, then do we leave it blank? Okay, let's leave it blank. Otherwise, take the minimum of all the cells around us and add 3 because it's 3 feet per cell. Okay, now let's see what happens when I fill this in. Formulas only. Ooh, what is that number? That's going to be 303. That's because there's something in here. All right, let's try. If I delete those, no, if I turn them into zeros, okay, that works. So I'm going to turn all of these stage cells into zeros, just so that the rest can calculate correctly. You need, whenever you do this kind of like iterative calculate, you need some kind of anchor. Otherwise, the cells will just keep going and going and going and going. And let's just check here. So these are at 69 and 72. They're not changing. That should be good. So we're going to call this distance, and we're going to call that distance map there. Now, once again, I do believe these should be fixed, so I'm just going to copy paste them as values. And then once again, I'm going to X look up the seat number from the address column here, and the distance is the last column I worked at, so let's do the last column. That lines up. Do the rest of these line up? Yes, they do. All right. Level 5. For the given concert, what is the height of the given seat in feet? Height is dependent on the tier the seat is in and the row the seat is in. All seats on the floor have a height of 0 feet. Every tier will increase in height above the last row of the prior tier based on the extra height between tiers information on the tour list tab, which varies by city. Every row will be an additional 1 foot higher than the row in front of it. This includes seats in row 1. All right, so if I look at the tour list, so we have, oh wait, let me just check. We have concert number and seat. I look at the tour list, we have concert number, that should match up there. And then, oh, here we go. We have the extra height between tiers. Okay. So let's copy these instructions. I'm going to work off of this sheet again. Let's put these instructions over here. And I think what I'm going to do is I'm going to do a data table runner here. So we're going to go game, what level am I on? Example 5. Okay, example 5. And then, so that's the information from example 5, and these are concert number and seat. Okay, good. So that's all lined up there. Okay, so we're looking at concert number. Whoa, what did I do? I resized it out. There we go. Concert number 3. Now, when I look at the concert number, I need to pull up the extra height between tiers. I probably could have copied and pasted, but oh well. X lookup 3 in concert number, return concert, extra height between tiers. So, okay, so I know that between the tiers there's 11 feet. Now, in my map I have 5 tiers, and these tiers are up to 5 rows. So I'm going to do a 2x2 table here. So we're going to have, let's do tiers across the top, sequence column 5. We'll do rows across the side. All right, and let's figure this out. So the way I understand it is floor is always going to be 0 because it's on the floor. 1 is you're going to take a look at that first extra height, but then add a row for each row in there. So it should be this plus these there. Now for tier 2, first thing you notice is we have 4 rows. We could do, once again, add another 11 and then 1 for each row there. So we're going to take the max of that plus 11 plus, and then these are only 4 rows, so I'm only going to do 1, 2, 3, 4. Now I'm locking these because I want to copy over to the right. So I'm going to keep that column there. Yeah, the rows don't matter so much. Yeah, that should work. 3 is also 4 rows, so now I could check if my locking is working. That looks like it's working. 4 is 3 rows, so I'm going to take this up to 3. And then 5 is also 3 rows there. Now, I'm going to go ahead, or in this column, I'm going to do height. So, if... Actually, no. You know what? I'm not going to use... I don't want to use OR because I'm always cautious about using OR because it takes the entire values, but I want to do an entire column. So I'm going to do... Let's index this table. That's what I'll do. I'll index the table. So I'm going to index this nice big table, X match the row first. So X match this row into this first column here. And then X match the tier across the top of that table there. Now it's going to come up with some errors when I do this at first because yeah, the floor is going to be 0 and X's just don't matter. So to turn the floors back into 0, I could just do tier is greater than 0. Does that fix the stage as well? No. That didn't fix the floor either. Oh boy. Okay, well then let's do an if NA. That should work. If is NA that, or you know what? No. Let's do if error. If error, that whole thing, then just return 0. There we go. So now all the floors are 0, all the stages are 0. It doesn't really matter for the stages really. But let's check. Let's check N2. N2, look in values. I get 29. The answer is 29. Excellent, excellent, excellent. All right. So X lookup, I probably could have done it this way instead of using the find thing, but oh well. Return height there. We get 29. Let's copy all the game numbers and run it based off of that. Excellent. Everything checks out. Very good. Okay. Level 6. How much is the ticket price for the given concert and seat? Round the answer to 0 decimal places. The ticket price formula is based off that formula there. Base ticket cost minus $15 times distance minus $10 times height times cost multiplier. The base ticket cost is $2,500. The distance and height amounts are described in levels 4 and 5. The cost multiplier is described in level 2. Okay. That's pretty straightforward then. So let me just add a few rows here. I'm going to delete that for now. Let's do cost multiplier for this concert number, return concert cost multiplier there. And then here we're going to do ticket cost. And to do ticket cost, what I'm going to do, oh, I didn't copy that information there. Let's do that. There we go. So base cost is $2,500. All right. $2,500 minus 15 times the distance minus 10 times the height. And that's all in brackets, I remember. Times, and there we go. times the cost multiplier, which is there. Okay, and we need to know the cost for that seat in that concert, rounded to 0 decimal places. All right, so let's do that down here again. So we're going to XLOOKUP this seat number from this column, return the ticket cost. I forgot to round to 0. Let's do that now. Round to 0 digits. We get 2169. The example answer is 2169. Put all this in, run it based off of this cell again. And let's paste. Excellent, everything checks out. All right, finally, level 7. What is the sum of the ticket prices across all seats for the given concert number? Round this answer to 0 decimal places. Do not round any interim calculations, even the individual ticket prices. Remember that some stadiums have only 3 or 4 tiers of seats. Stage cells do not contain seats. They are never sold. Okay. So here, like what you notice here, these are stage seats, but I still have prices on them. We gotta take the prices out. We also need to figure out how many tiers, which is in this column there. So let's do stadium tiers. And look up that in concert number, return concert stadium tiers. Yes, there we go. Now we're going to take this ticket cost here and we are going to add 2 true and false statements. The first one is if the tier does not equal X. And the second one is if the tier is less than or equal to the number of stadium tiers returned there. So what this does is, for example, here, this concert number 3, there's only 3 stadium tiers, right? Yeah. And so anytime there's an X, it's going to be 0 because that's a stage, but every time there's a 4 or 5, that's also going to return 0 because there's no tier there. Now, when I get the sum of all these, round to 0 digits. Ooh, I forgot the word sum. When I sum all these, like I said, I get 3474142. Oh, I am somehow off by $72. That's an impressive number to be. Oh, because I'm on the wrong example. Example 7. I have the same answer. Okay. Why do I have the same answer? So right, so tier 3. Yeah. The height checked out. Am I counting all the cells here? Oh, I have a different answer there. Why do I have a different answer there than here? Oh, because I rounded in the wrong spot. You gotta round outside of the sum. There we go. See, it's important not to round interim calculations so you don't make mistakes like that. All right, let's copy and paste the answers from that data table there. Everything checks out. Excellent. Let's go ahead and take a look at the bonuses. Bonus A, what is the anklet value of anklet 1? Information on how to calculate the value can be found on the anklets tab. All right, let's take a look at the anklets tab. Each bead final value is the bead value in column F times the next bead multiplier in column G, which is based on the prior B. The total anklet value is the sum of all the beads' final values plus the extra value in column J for each bead string in column I in the anklet. Wow, okay. So we need to find the bead final values plus the extra value to get the total value. Okay, so we're going to do anklets. This is number 1. Beads. Actually, no, let's do index because I think these are just in sequential order. So that's going to get all the beads for that anklet, and we need to find bead final value, bead string value, and total anklet value there. All right, so we're going to work off of anklet 1. These are the beads. Let's do this in a table. So let's do bead. I like to use my regex extract for this. Dot means any character, return them all. So that's going to get all the beads right there. Now we need to get the value. Return, look up that in this column and return the value there. Okay, we have some errors, and the reason why we have errors is because, you know, comparing a text, regex extract puts out a text versus this column where some of these down here are going to be numbers. So I'm going to cheat the system by using a left function to turn them all into letters. There we go. So that gets us all the value. And then we need the multiplier. So we're going to take this same formula there, but we're going to take it against the G column here. Now, the tricky thing is the bead multiplier is about the next bead, not the current bead. So I need to shift everything down, and the first bead is going to have a multiplier by 1. So I'm going to V stack 1 with all of that, but then we're going to get one extra row at the bottom there. So I'm going to drop that last bead in my multiplier column. Oops, not 1. That should be a -1. 1 is first. I want to drop the last. There we go. So now everything is shifted down. The first bead has a multiplier of 1. Where the value is going to be this column times that column. So the bead final value is going to be the sum of all these values there. There we go. Now the bead string value, to get that, we need to compare these strings into basically the bead list there. So I'm going to do is number search these strings into that string. So it's either going to give me true or false. True if it's in there. This one is in there. Which one is that? I think that's 12 AMS. Yes, I see that right there. So now we're going to take that. Now true and false is equivalent to 1 and 0 in Excel. So I take that, multiply by the extra value. That's going to give me the value of all the extra beads strings in there. Sum all that together. So that's going to give me my bead string value. Sum those two numbers together. My total anklet value for anklet number 1 is 297. Bonus B, how many times does 1987, which is Seamstress Fast's most popular album, appear across all the anklets? So here we have all the anklets. We're looking for how many times this 1987 appears in them. So we're going to sum is number, search 1987 into all of these. So that's going to turn it into trues and falses. The double negative is going to turn it into 1s and 0s. Sum them all together is going to tell me how many of those contains that. My answer is 3. That checks out. Bonus C, which anklet number has the highest anklet value? Okay, well, I only did this for 1. I guess let's do it for all of them. So I'm going to do all the anklet numbers there. Let's bring this in here. We're going to return this total anklet value and run this as a data table. There we go. Right, we need to find the maximum. So we're going to XLOOKUP this giant number from this list, return from that list, but return the exact match or next smallest. That's going to give me number 27, telling me number 27 is the highest anklet value. Bonus D, what is the sum of all the anklet values? Oh, goody goody, I can tell you that. Excel said that 15,226. You notice I copied that from this. I forgot the name of the bar at the bottom. I think it's something like, I forgot the name. Bonus E, you are given a set of 7 beats, A, E, F, M, R, S, T, the letters in Seamstress Fast. You can choose any 6 of these. What is the highest anklet value you can get? You can use each of these beats only once. So we have these letters, and we can make an anklet of any 6 of them. So this is a permutation problem. We're going to need to find all the permutations of any of the 6 letters. So what I'm going to do is I'm going to start another sheet. We're going to call it bonus 5. Let's split these up so they're separated by comma there. A, F, M, R, S, T, good. To call that there. And what I'm going to do is I'm going to take this array and, no wait, let's start with the left array. Left array and top array there. So that gives me all the possible 2-letter combinations. I'm going to do this again. This left column now is going to be to call of the output there. So that's going to give me all the 3-letter combinations, 4-letter combinations, 5-letter combinations, and finally 6-letter combinations. Now the thing is, these are all the letter combinations with repetition. So this is 6 A's, but we're told that we can use each one only once. So instead, what I'm going to do here is I'm going to count how much of each of the letter is contained with them. So this is done by a nice length substitute combination. So the length of all these minus the length of substitute from all these letters here, replace them with blank. So that tells me how much of each letter is in there. So we have 6 A's and nothing of anything else. We are going to take the maximum of each row. So that tells us how many letters are in. We only want the ones with only 1 letter in each of them. So we're going to filter this list where this is equal to 1, where the most letters in each of them is 1. Now we have a list of 50,040, which later I'm going to show you the math. That does check out. Let's go back to our anklets tab. Let's replace this with all of those in there. Remove that data table for now. And this is going to run the data table, I need to take this out of the formula, return a simple string. run the status table in there, use my status bar, find the max is 116, paste that into bonus E, and that solves this case with a full score. Wow. Wow, that was fun. Again, I apologize for if you can hear some noise. I also apologize for my mouth. I think coming down with a cold. This is a time where the seasons are a-changing. Now that I saw this, let me just talk about this bonus E a little bit longer because it took me a while to try to figure out what's the best way to return all the permutations of this. And you saw what I did was I created these tables here. So any combination or there are a total of 49 permutations of 2 letters with replacement. And that's basically what I've done up here. I've taken these letters, added the letter to them, I get 49 results. Now, if you wanted to do 3 letters, that should be 7 times 7 times 7. Once again, that's with replacement. I get 343. But if I also count this entire range, I should also have 343, which is what I do. So this is telling you that this is a way to find all of the permutations of however many letters, however many number of times. What you see here is that I did this in a way that's kind of repetitive. And so I feel like this is something that a recursive lambda can do. In fact, Bo has come up with a really nice percom lambda, which kind of does this. It returns all the permutations of a given number from a given set. Last time I talked about permutations, Dim left a nice comment and left a video where he talks about recursion and how to do it in Excel. Unfortunately, my 2 brain cells aren't enough to understand much of that video, but I do appreciate that from Dim, and I'm going to leave a link in my video here in case you want to watch it. The one thing is this is permutation with replacement. So you see I got 4 A's in there. And so at the end, what I had to do to take that replacement out was I had to find out how many of each character is within each set, but then I only want ones where no character is repeated. So here, this is like some character happens 6 times, some character happens 5 times, and so on and so on. And it's only we get down to, can I find a 1? Let me just find a 1 in here. Look in values, yeah. So there's a 1, AEFRMRS. Each letter is only used once. So that is one of the first ones that gets taken out. And so that is where we're left with 5,040 remaining results, which once again, if you're counting without replacement, that's 7 letters plus 6 rest to choose from, plus 5 remaining to choose from, plus times 4 times 3 times 2 remaining to choose from. That will also get you 5,040 possible solutions. So this is a way to collect all the possible permutations. Now, after doing this, I was thinking that there is a way to do it without having to filter at the end. But you are going to have to filter then as you go on. So let me show you like another option. So B5-2. Let me bring these in again. But this time I'm going to change this function. So if is number, search this top row in this left column, then return blank. Otherwise, return this top row and this left column there. So you see this is number search is saying, is this top column anywhere in this left side? If it is, don't give me an answer because I don't want to count it. So you see your double A, double E, double F, double M, double R, double S, double T do not show up here anymore. Now let me repeat this. So once again, this is going to be to call of this array. But then the tricky thing is that's going to bring up the blank cells. And even when I do this ignore blanks and errors, that still brings out the blank cells. I'm thinking there's something in Excel about blank cells versus null cells, and Excel sees this as one or the other. So to get this to work, you're going to have to filter it out here. So filter this where this is not blank. Now that's going to give you the proper list, and now you can repeat it. So that's 3 characters, 4 characters, 5 characters, 6 characters there. One more time to get your final list of 5,040. That works as well. At one point or another, you're going to have to filter out your list to remove all the repeats. If you decide to do this option, of course, maybe there's a better option to find all the permutations. But there's your full solve of this case. A really fun case. Thank you, Peter, for writing this case. I like the fact that it kind of got a little bit financy, but not too financy. It was done in a way that everyone can understand really easily because we've all bought tickets to something at some point in our lives. If you've enjoyed this concert, please do give me a like and a subscribe. Check out the links in my description because I always put how you can download the case if you want to give it a try. And I always put links to other solves from other competitors that upload them to YouTube. So you could take a look there. They might have different strategies than I do. It's definitely worth checking out there. But thank you for watching this channel, and I look forward to seeing you for my next video.
It's the Excel world.